Our next example. For the point 6, 8, find the three primary trig ratios and the angle it creates in standard position. So first, I'm going to plot 6, 8. So we have 6, 8 right there. And since this is a point on the terminal arm, I'm going to draw a line from the origin all the way to the end. So this is our terminal arm. This is just a point on it because the terminal line or the terminal arm is just a nonstop line. Now I'm also going to draw a perpendicular down and have my initial arm there. What that does is now I can label this as angle A because we know that standard position by definition is the angle that's created from the initial arm to the terminal arm. So on the way to finding this, we need to use this triangle and work backwards. So I'm going to label this. This is 6 units. This side we know is 8 units. And we need to use Pythagorean relation to get the hypotenuse. So I have 6 squared plus 8 squared equals c squared. 36 plus 64 is c squared. 100 equals c squared. And the square root of c, or square root of 100 is 10. So 10 units is our hypotenuse. Now I have my opposite, my adjacent, and the hypotenuse there. So sine A is opposite over hypotenuse. Cosine A is 6 over 10. And tangent A is equal to 8 over 6. Now this is the final answer if I'm only looking for my primary trig ratios because I've found the ratio 8 over 10, 6 over 8, 8 over 6. But the second part is asking us to find the angle in standard position. So I am going to undo the sine, cosine, and tangent so that I can find what angle A is. I don't have to go through to find every single one because I know that A is going to be the same in all of them. So let's undo sine. Inverse sine of 6 over 10 is equal to 37 degrees. So that means it's 37 degrees here. I'm going to do the same thing with cosine just to show you that cosine A and tan A all have the same A. So inverse cosine of 6 over 10 is equal to 37. Inverse tan of 8 over 6 is also equal to 37 degrees. So we can write our conclusion. In conclusion, in standard position, the primary angle A is 37 degrees. So this one was nice because this was our primary. It started from our initial arm and it went to the terminal arm. Let's look at our next one. For the point -5, 12, find the three primary trig ratios and the angle in standard position. We have our point here, -5, 12. I'm going to connect it so we have our terminal arm. Normally, we have this angle here, and I'm actually looking for this because that is the angle in standard position. Now, I'm not going to be able to do that because I don't know the distance of this. However, I could drop my perpendicular so that I create a right angle triangle. And since I know that this angle is related to this angle, I'm going to be able to find the primary angle in standard position. Okay, so I've drawn my line here to create a right angle triangle. I've put my angle B. The horizontal, it's 5 units in distance, but since we're in quadrant 2, we're going to write -5 units. Our y, or the height, is 12 units, and we're going to use Pythagorean relation to get the hypotenuse. So -5 squared plus 12 squared equals c squared. 25 plus 44 is equal to c squared. 169 is equal to c squared. Square root of 169 is c. C is equal to 13. So we have 13 units for our hypotenuse. Okay, so just to reiterate, we have our opposite here, adjacent is here, and the hypotenuse is here. So I'm going to write my trig ratios. Sine B is 12 over 13. Cosine B is equal to -5 over 13. And tan B is equal to 12 over -5. Now, when we get our angle, we're actually going to be getting different answers for each of the angles, and I'm going to explain why in a bit. But just remember that the related angles are very similar to each other. So we have B is equal to inverse sine 12 over 13. B is equal to 67. Now, this is the related supplementary angle because this is an acute angle. Now, for us to find it in standard position, we need to start from the x-axis. So we're going to take 180 minus 67, and that's equal to 113. Our next one, we have cosine B. Now, when I undo it, it's actually going to give me 113 degrees. The calculator is kind of funny. The calculator has given us the standard position. Now, it's because the calculator doesn't know whether we are referring to this one or whether we're referring to this angle. So we see that this number is greater than 90. This is an obtuse angle. So we can say that this is our primary angle. So this is the angle in standard position already. Now, finally, we have our tan. To undo our tan, we are going to have B is equal to -67. Now, when I have a negative answer, it just means that we are going in we're going in clockwise direction instead of counterclockwise. So what this B is telling us is saying from this axis all the way up to this line is 67. So once again, I have the related angle, and I'm going to have to work my way around to find the obtuse angle. So this is the related supplementary angle. And in standard position, we are going to take 180 degrees minus 67 is equal to 100.